Hey guys, today's video is all about fine tuning. We're gonna see what is fine tuning and why it is required. At the end of this video, we will also see a simple tutorial on how we can fine tune a pre-trained model using Hugging Face transformers. Okay, so let's get started. But before everything else, let's understand why we need fine tuning, right? At the first place. So we all know that large language models basically hallucinate. They provide inaccurate answers, and sometimes they provide answers that are inadequate, not contextually relevant, and sometimes biased answers. So we call this behavior of large language models as hallucination, right? Hallucination of large language models. And to mitigate this hallucinating behavior of large language models, we have basically three prominent strategies. One is RAG, retrieval augmented generation. Second one is prompt engineering, and the third one is fine tuning. So RAG is where you basically augment the LLM application with custom data that is present in a vector database, so that the LLM or the AI application can easily retrieve the relevant chunk or information from vector data using different techniques like vector search, hybrid search, and all that. So that's it about the RAG, which is quite trending these days. And then comes the prompt engineering, where we basically play with the prompts, right? It's basically the art and science of playing with your prompts, right? To see for this particular input, prompt input, what is the output, and then making corrections with our prompt, and then seeing the output again. So that's about the prompt engineering. And then comes the fine tuning where you take a pre-trained model. So these pre-trained model like GPT and all, they're already trained on massive data set that is, from anything on Wikipedia, internet. So they're already trained. So that's why they are called as pre-trained models. So we take these pre-trained models and then we train that pre-trained model with our custom data so that it starts understanding the our use case and the vocabulary, and then it basically adopts to our use case, and that's how it starts reacting to the prompts that we provide. So that's it about fine tuning, where you basically take a pre-trained model, you add your own custom data to train that pre-trained model. So in the next part of this video, let's understand, how we can basically train a pre-trained model using Hugging Face transformers. So like I was saying, right? So you basically take a pre-trained model, a large language model in fine tuning, which is already trained on a massive data set that is present on the internet, Wikipedia, YouTube videos. So it is already trained. So that's why we call it a pre-trained model. So we take that pre-trained LLM, it can be BERT, it can be GPT. So all these pre-trained models, and we basically train these pre-trained models using our custom data. So as you can see, a custom knowledge base we train, and then that's how you get a fine-tuned large language model which can be used for your use case. Okay, so just for example, if you are working in a healthcare sector, right, a healthcare company, and the pre-trained large language model won't be understanding your vocabulary, right? So that's when you need to train that pre-trained model with your custom data so that it adopts to your use cases and starts understanding your vocabulary. So that is why we need fine tuning. Then once you finally, fine tune the pre-trained model with your custom data, now you have the fine-tuned large language model, which can be basically used for different purposes, right? See, like question answering, language generation, language translation, sentiment analysis, summarization, and many other things, right? You can also use it as a chatbot, so that when a user comes into your website or to wherever you're working, so it can answer back to the user just like a support system or a support AI agent. So that is the use of fine tuning basically. So as you can see in the image, right, the first image basically depicts the accuracy of the different strategies, right? So prompt engineering basically has less accuracy compared to RAG, fine tuning, and training the LLM from the scratch. Whereas, RAG and fine tuning, if you compare, the accuracy of RAG is little lesser compared to fine tuning. And then if you compare fine tuning and training an LLM from the scratch, obviously, right, the training an LLM from the scratch will have more accuracy levels compared to just fine tuning, right? So that's it about the first image. Again, right, if you compare the computational resources, the GPUs and all that required will be exactly opposite to the accuracy levels what we saw, right? Because training any LLM from the scratch would require higher levels of GPUs, the computational power, the effort, the people required. So it's obviously more. And then again, fine tuning requires little more computational resources than RAG, because a RAG revolves around embedding models, basically converting all your data into vector embeddings and storing those vector embeddings in a vector database and then vector search and all that. So that's it about RAG. And when you compare prompt engineering and RAG, again, the computational resources and the effort required in prompt engineering will be much lesser than RAG. So yeah, so that's it about the different strategies like prompt engineering, RAG, fine tuning, and training the LLM from the scratch. But if you see the second image below, the external knowledge required, and then the model adaptation required, example, behavior, writing style, and vocabulary. Of course, fine-tuning an LLM will have more adaptation with respect to the behavior, writing style, vocabulary compared to RAG. In RAG, you need more external knowledge, right? Whereas in fine tuning, you are basically fine tuning your pre-trained model with your own custom data. You might not require that much external knowledge here. So that's it about the second image. So in the next part of this video, let's see a simple tutorial how we can fine tune a pre-trained model using Hugging Face transformers. Thanks. Hey guys, finally it's tutorial time. So what we're doing here is basically fine-tuning a pre-trained model using Hugging Face transformers. Here is my complete notebook code, which I'm going to share the link in the description of this video so that you can go through and try to understand how you can fine-tune a pre-trained model using Hugging Face transformers. So yeah, I'm basically using SingleStore's notebook feature here. So if you're new to SingleStore, SingleStore is basically a relational database company which started supporting vector storage long back in 2017 itself. And you can use SingleStore as your vector database and also use SingleStore to build your LLM powered applications. So go to singlestore.com, sign up. SingleStore has a free share tier which you can use, right? So once you go to SingleStore dashboard, you can go to Data Studio and try to create a new notebook. So let's get started with our notebook here. So steps for fine-tuning a pre-trained model. These are some simple steps, like we need to choose a pre-trained model first, whether it is BERT or other popular choices that we have. Next is to prepare your dataset to ensure your dataset is properly formatted, right? For test tasks, this usually involves tokenizing your text data. You can use the tokenizer provided by the transformers library. So to convert your text into input IDs and attention masks. So next is to set up training arguments and then create a trainer and then train the model. And after training the model, let's evaluate the model. So these are some simple steps to fine-tuning a pre-trained model, right? So then the goal here of fine-tuning is basically we are going to train a model using the Yelp review dataset, right? The primary goal is to fine-tune the pre-trained model so that it can accurately classify the sentiment of Yelp reviews, whether the uh, the customer review is positive or negative. Okay. So first things first, install all the necessary libraries, right? Like I said, we are basically using Hugging Face transformers. That's what we are installing. And next is so you'll also need to install your preferred machine learning framework, whether it is PyTorch or TensorFlow. I'm using PyTorch. And then begin by loading the L preview dataset. Here is my L preview dataset, right? I'm loading the dataset here. And yeah, and then tokenize the text data to prepare it for the model. That's what we are doing. We are basically tokenizing the data, right? This is our model, BERT based. So we did that, and then also, if you like, you can create a smaller subset of the full data set to fine tune on to reduce the time it takes, because it takes a lot of time. So you can basically create a smaller subset of your full data set. That's also you can do. And the next thing is to train with PyTorch trainer. So that's what we are doing here. And then training hyper parameters. That is what we are doing here, right? Create a training arguments class which contains all the hyperparameters you can tune as well as flags for activating different training options, right? So that is what we are doing. We basically training with the PyTorch trainer, and then we are doing creating a training argument, right? And then once we do that, we're basically evaluating our model, right? So trainer does not automatically evaluate model performance during training. So we'll need to pass a trainer function. Okay, that is what we are doing. And then uh, we are creating a trainer object with our model, training arguments, training and test data sets to and evaluation function. That is what we are doing here. And then the basically finally we are fine tuning the model by calling the train trainer. Okay, so as you can see, we received this after fine tuning. It's gonna take some time, maybe half an hour or an hour or so. So after that, you're gonna see these metrics like training loss metrics, train samples per second. So I'm gonna explain all that epoch, right? Train steps per second. So here is a detailed explanation for each component, right? Global step 375, what does that mean? It basically, right? This indicates that the number of steps batches the model has been trained on. And then the training loss is almost 0.977. So the average training loss over all batches and epochs. Loss is a measure of how well the model is performing on the training data, right? A lower value indicates better performance. Here, the training loss is approximately 0.978. So, metrics train runtime 4605.03. So, the total time taken to complete the training. So, that's approximately, like I said, right, 1 hour, 17 minutes it took to basically fine tune that model. Train samples per second 0.651. So the number of training samples processed per second. Train steps per second 0.081. So the number of training steps processed per second. Yes, the same thing. So yeah, and after that, let's evaluate the model. So after training, you can evaluate the model to see the performance on the evaluation data set. So again, we got some metrics like eval loss, eval accuracy, eval runtime, right? So here is a complete explanation of uh, all these things, right? Eval loss and all. So what is eval loss? Eval loss was almost 1.00. So the loss computed on the evaluation, right? Validation data set, similar to training loss. It indicates how well the model is performing on unseen data. Here, the evaluation loss is approximately 1.002, and then eval accuracy is 0.606. So an accuracy of 6.606 means the model correctly classifies 60.6% of the evaluation samples. Not that good, but it's okay, right? And then eval runtime. So basically, this evaluation ran about 5 minutes 6 seconds. So yeah, so what we did was we successfully fine-tuned a pre-trained model, that is BERT, on the L preview dataset. The model adapted its general language understanding to the specific tasks of sentiment analysis on L previews because we basically used ELP dataset, L previews dataset. So yeah, you can go through these steps and try to understand how to fine tune a pre-trained model. I'm going to share the link of this repo in the video description. Thanks.